thanks everyone for making it here. Hopefully we'll be finished quite quickly, but I'm going to talk to you about a story that we had. Firstly, my name is Kon Soulianidis. I am from Australia. You may not have guessed that. On the taxi on the way here, people are like, "Oh, you're from the UK?" I'm like, "Oh no, maybe I've got a cold or something, and my accent sounds different." So here we go. No, we'll just go to this. No, we won't even do that. All right, so this is where I'm from. I tried to find the most accurate map of Australia I could possibly find. I live down around here in Melbourne, which is near giant spiders and convicts. You can swim across and you get to sharks with frickin' laser beams as well. It's actually quite a menacing place to live, and it's amazing that we get any web development done at all. But we still managed to do just that. Another part of Australian culture is, of course, beer. So I am conscious that this is the last session of the day. And I've got a feeling somehow that it might not go for the whole 90 minutes, which means we can get out a bit sooner as well. So I'm here. I thought it was worth getting on a plane and coming to America to talk to you guys about using Gradle to build a JavaScript web app. Like most people, we had to build a single page web app, and we went and started using tools like Grunt and Gulp, and basically hit a hurdle very early on with NPM. So we had to get a plan B, which was Gradle. And it turns out that Gradle has got quite a few different tools already, plugins that some of them have been left to the side, but a lot of them are still being maintained actively. In fact, in yesterday's keynote, Luke Daly was looking up in the new plugins portal the JavaScript plugin that I'll be demoing today as well. So yeah, and then in the end we delivered something with this. So you'll see in a sec. Just a show of hands, are you guys all web developers at all? Done a little bit? And yeah, Ken's going on. Chuck Norris Android apps, there's got to be a balance there somewhere. So no experience necessary. The good thing about taking Gradle and using it with a language that you don't know so well, like JavaScript, is that you also get to learn Gradle really well and learn to understand with different kinds of tasks what it's capable of doing. So that was kind of exciting because you start actually exploring source sets a bit more and start exploring tasks a bit more. Whereas I guess you can copy and paste a lot of Java Gradle, like so Java and Groovy Gradle, you can just apply plugins, and if you just follow the standard Maven structure, you'll be right. You know, and then this was a little bit different because it's not stuff that comes out of the box with Gradle. So a lot of the time you have to look at the source code, and then a lot of time you just start using extra features. So you start reading more of the Gradle user manual, going further and further down the chapters. So what I'll do is I'll talk about the application that we built, and then I'll show you step by step all the different parts that we did as if you were going to build it from scratch. All right, this is how you get me. Never sleeps, and it's quite true with all the jet lag I've had this week. I'm starting to settle down now, which is good. So. Just about to jump back on a plane on Wednesday, so I'll be right for when I get back home. Do it all over again. So a bit more about me. I wear two hats. My passion is I run the Melbourne Java and JVM user group back home, and so it is proudly Australia's largest Java user group. I've obviously got a big Java bias, so wear Java on my sleeve, and Java to me is not just Java, the language, it's Groovy, it's all the other languages. It's picking the right tool for the job and having that flexibility behind you. And the most exciting thing about Gradle is that it actually allows you to pull all these different things, actually not just from the JVM, but just from all different kinds of stuff. So I don't know if you guys saw, there was a presentation with the guys from Prezi, and they don't actually do any JVM languages. They're using Gradle, but they're building JavaScript apps, and they're building mobile apps with native code. So that was really eye-opening to me. But it's great, and yeah, so Gradle is hot right now. we had Luke Daly come down last year in September and basically plant a lot of seeds and get a lot of people on board. The other half of what I do is I work as a consultant at Shine Technologies. Shine Technologies is a boutique consultancy, about 50 developers, but we've got lots of large corporate clients, so big telcos, big energy companies, and in this case it's a media online digital delivery of advertising. But the number of JavaScript projects is going up, so we've got basically a lot of us that are quite got a forward bias towards using JavaScript, and they do credit to them. It's they get stuff done with it. They go and speak at conferences about it, and then there's me going the other way. So what we try to do is it's good to learn both sides of the thing, and so basically we just try to put things in line. There's a couple of things. So Gradle, obviously, for one, with all its plugins. Nashorn with Java 8 being the other. There's been a great thing to help propel the movement forward. So the app that we built, it's quite a simple app, but the domain, it's online advertising. So our client runs advertising off some of Australia's most popular websites. So they'll basically create products that they sell to ad agencies, and agencies then provide inventory or provide ads to put on those websites. And so what the advertisers want to know is that once they run an ad, who's actually going to see that ad, all the demographic data. So the client has got all these users on their website. They know all the demographic data about them, their age, their location, and so forth. And then they want to run an ad, and after the ad's been shown, aggregate who's seen that ad, so that then they can, for the next time that they run that campaign, they can filter down further and further and maybe better target that ad. So yes, we built a proof of concept reporting app to start with, and JavaScript was a good choice for this because it's just very throwaway code, and this was before we basically started with a single HTML file and then brought in the libraries that we needed. The application, I'll just talk through what I'm showing you here. So there's basically different demographic stuff that they can choose. Actually, I've got a demo which is even better. It looks probably better on this. I'll switch across here. All right, so I'll go through this first, sorry. Basically, users visit websites and we log what I was just saying before. We log what they've clicked on, what they've seen. And the advertising engine behind that logs all that into Google Cloud Storage, of which then we've got some Java tools that read that and then run some summary queries on that, sort of like a bit of an ETL, if you're familiar with that. So we basically use Google BigQuery, and Google BigQuery is like Hadoop, but with an SQL front end. So you don't need to have any MapReduce skills. Google take care of that behind the scenes. You just write normal SQL, but you upload effectively CSV or JSON files, and behind the scenes you don't have to index anything or do anything. Google just go and run that query and get it back. But the thing is, it's amazingly fast. So you can get back, aggregating over terabytes of data would take minutes, whereas say with a traditional RDBMS like Oracle, you'd be there waiting hours, and you'd have to also put index on your data set first. So this is basically good to go out of the box. So this works very well for us. It comes with a REST API which we then use a Tomcat to talk to it, and then we've just basically built this reporting front end and all the business users within our client so run reports and give that data back to their clients around who's seen their ads and how they can better improve their campaigns. So just to prove that it's a real app, I'm just showing you how it's launched. So over here, it's just using the Tomcat plugin. So Ben, you've already seen at the start of the conference, he did it. He wrote the plugin, and so he's it's basically running an embedded Tomcat in that container. The BQ tools is the part that is the SQL, the interface to Google BigQuery. It just produces a jar that gets included into this web app over here. And then we've got some tasks that prepare our stuff there, and we run the next thing. Sorry, did I go a bit fast on that? You got an idea? All right. So basically, I just want to see if there's... All right, this is better. So user signs in, and they select what parameters that they want to report on. There's some filters there. They're not showing up here, but they just take my word for it. There, and so they're running some reports, and we can get a breakdown. So here we're getting gender between male and female, location as well. So what state of Australia that they live in, the age range, and the hour of the day that they browsed. And quite quickly we can get some pretty good insights about what people are browsing. So for example, with this hour of the day, 3 p.m. is the most likely time that people are clicking on ads, along with 8 p.m. at night. The other thing too, so we're basically saying how many clicks per, the ratio between impressions and clicks. And basically you can go to an advertiser and say, people are more likely to click on your ad at that time, you know, when you want to sell something to them. The other thing too is we found that people over 65 also have a high tendency to click on ads. We don't know if that's just because they try to click on something else and they accidentally missed. But what's your experience there, Darren? 61, all right. So you're not doing, I think you're on par with the 35-year-olds actually, so you're not too bad. So yeah, so this was very quick. We got this out within like the base app within a week, and then we dressed it all up over the course of the few months. But being able to do these insights really quickly helped our client, and it was a very agile team. It was just 2 developers and 2 product managers really, and it was just throwing ideas back and forth. Even just to have the line for doing the click-through ratio was just something that we did on the fly, and we could experiment very quickly until we really knew what we were doing, I suppose. And then we just continually added more reports. So it's pretty basic as far as a web app goes. It's just jQuery and Bootstrap, and then Google's libraries for talking to the back end. So they just provide, it's a RESTful, everything's RESTful APIs, but they provide wrapper client. So for JavaScript and for Java and what else, Python and you name it, there's quite a few different client libraries. They all talk over OAuth 2. Sorry, anyway. And the last thing was this Google Charts and Visualizations API. So that just, there used to be an old version of Google Charts API, which was just give you a static image. This one's actually quite nice. You probably saw it in the demo as you hovered over stuff. It had popovers. It's all SVG. It works in mobile browsers just as well as normal desktop ones. So it was quite easy to pull those guys together. The Bootstrap and the jQuery, I'll go through later, but we just downloaded those jars. Sorry, those jars. I'm talking like a Java developer here. Downloaded those libraries and included them in the source. These 2 guys, you actually have to reference off Google's website, because I'm sure they do some sort of analytics, even though they're not capturing your data. They're just seeing how often that's used. So, all right. So, yeah, we started to. I'll talk about how we started getting onto moving away, or getting onto Gradle. So we basically were at that stage where we now needed to make this a proper thing with tests and a bit more of a stronger development platform. And yeah, we wanted to be like this guy, so the Java hipster. So, you know, Java gets a bad rap, and you see all these people doing cool stuff with Angular and Bower and Grunt, and you go, oh yeah, I want a piece of that as well. And so, people will go up and say, why don't you use, Grunt or whatever? And I'll explain through that what I mean. This picture, by the way, is from a project called JHipster. And JHipster is a combination of Maven, Grunt, Spring, MVC, AngularGC, and Yemen. And wraps all those things together. So it's a Yemen generator, which has full hot reload support. And it was Maven only up until a few weeks ago, where they just announced Gradle support, so it's probably worth mentioning here. But the reason we couldn't even use this, even if we wanted to, is because this all runs off NPM, and we work in a normal corporate IT environment with proxies, and so NPM gives you a way to set those proxies, and that's all cool. Then you go to run NPM, and it goes, okay, I'm going to go look up some stuff, and then this happens. This yucky SSL 23 get server hello unknown protocol, and what's going on there is that just something to do with the certificates. The way the certificates are handled via the proxy is set up incorrectly. This particular error affects all kinds of Unix tools like wget and git and everything. And there's basically a flag. So if you look on Stack Overflow, their recommended thing is, I'll use the flag which says don't do a security check. So do you guys remember a few months ago there was an iOS issue? They did a hotfix, I think it was around 703 or 704, where basically all transmission, even if it was going through a HTTPS, it wasn't actually secured. So even if the certificate didn't match, it would still go through anyway. And that's because basically there's a flag where if you're not careful what you're doing, I'm not saying that this is what caused the error, but it's the exact same effect where they were just ignoring the result of the SSL handshake. And so, basically Stack Overflow tells you to to put that flag on so you can get around the problem, which I suppose is okay for development, but sometimes if you want to actually, if you forget it in there in your environment or something, you're pretty up for more trouble. So our options were quite limited because we couldn't go to our to the corporate IT and say, go and fix your proxy. That would take weeks, and we couldn't. We could probably plug in our dongles, but then we'd have our CI servers, which we'd have to also then worry about. So it seemed like a bit silly. And of course, we had Grunt. So we were almost on our way, and then had to think about Plan B. So I went to Java 1 last year, and there was a BOF about JavaScript, basically because, of course, Nat and Nashorn coming out, and it was, what can we do to help the two camps meet? Like, surely, like the Java guys have got a lot of stuff to learn from the JavaScript guys, and vice versa. And one guy there was particularly passionate about Java. He said that JavaScript was climbing the development tree of software tooling, and basically climbing all the way up and falling down, taking each branch on the way down, and basically meaning that all the same tools were getting reinvented on JavaScript. So, Maven had solved dependency management ages ago, but here we are going building new stuff yet again. And for better or worse, that's the way it is. And I think that's one of the reasons why we had the problem with our proxies. It's just that things weren't battle tested long enough and hard enough to make proxies isn't going to be the first issue that anyone really cares about when they're developing a new tool. And the thing about JavaScript world is that this moves very, very quickly. So there was a blog post around the same time we were battling with this issue. Basically, and just like that, Grunt and Require.js are out. It's all about Gulp and Browserify now. And this reminds me of the book 1984. There's a scene in that where basically there's two countries at war, and one day the government just announces that, oh no, it's not that country that we're at war with, it's another country. And everybody immediately rips down any propaganda posters that were about the former country and basically pretends as if they were always at war with this new country. So you know, this sort of permeated throughout the internet with regard to gulp and grunt. So this was some tweets I also saw at the same time. You know, so it's also like, oh man, this is going so fast. You know, if these guys can't fix my proxy issues, what's the chance the next guy is going to fix them? But also, who's going to spend the time to want to go and look at all these things and go and learn a new tool only to then, you know, start again? So it was a little bit frustrating, but kind of good to know. I know you can't hear this. This is just the movie, and this is where the main character's basically been told he must believe that they were always at war, and he's been tortured for ages, where he's now come to the realization, no, I don't know who we're at war with, and it's like, that's the right answer. And yeah, how many fingers I'm holding up, that's meant to be 5 fingers as well, and he'll just happily answer 5. So it's a good time to introduce something I don't have to consider 5 fingers or a different. This is more real. I've built apps with Gradle before. It's quite easy to do stuff with it. This guy here, he's a hero. His name's Eric Wendelin, and he writes the JavaScript and CSS plugins for Gradle. They basically, a lot of tools just basically build off existing tools. So back in the Maven days, this Google Closure compiler is just a jar that you include, and it goes and minifies your JavaScript and does a whole bunch of other cool stuff. And the Yahoo UI compressor does equally the same with your CSS. So these two guys are what these plugins just basically wrap up and do all the Gradle-y kinds of things, like manage the source sets and feed those into the tools. So, yeah, as I said, Angel. If you know this guy, I think he works around this area. So go and buy him a beer. Go and buy him a beer, because he doesn't work for Gradle either. He's just done it off his own bat, so it's pretty good. All right, so if you're going to start a Gradle JavaScript project, this is how you do it. You've got a JS plugin and CSS plugin. You then try to do that and realize you've got to include the build script dependencies as well. Pretty straightforward, or as you saw yesterday, you can use this new plugin mechanism, which would be nice, a bit shorter. Most of the time it's up to date. So I found in between like version 110 and 111, something broke with the plugins and basically stopped working after that, only until a week or 2 ago did these issues get fixed and brought up to speed. But the good thing is the community around it's pretty decent. So if there's anything that's a shortcoming or broken, the GitHub issues or looking at the pull requests on the project itself is a good way to find someone's probably fixed the problem. And so to get the CSS plugin working with Gradle 112, for example, is a matter of just looking at that tree in GitHub and going, okay, someone's submitted this pull request which fixes the bug, and then going off and building that version of the plugin and installing that, and that seemed to work around the problem. So it was good enough. At the time, I mean, maybe if at the time I had encountered this issue first, so if I was trying out all these different plugins, I may have not, I was just lucky that 110 worked with this and there was just a release roughly around the same time. I may not have gone and investigated as far, but I suppose I was lucky that it was. I'm here to tell you that it's probably still worth using and it's still being maintained. So there was that update a few days ago onto both of these plugins. And these are the things that you get. So all the combination stuff, that you need. You can gzip files. There's a less CSS compiler. You get all the minification. There's even require JS support in there as well. So I'm just going to take a step back and use a really dumbed down version of our app. So this is just the Twitter Bootstrap dashboard theme. And basically just pulled out some CSS files and JS files there. And really all you care about as an app is, yeah, those three guys. But then when we expand our libs directory, we realize that we've got Bootstrap and it comes with a dozen files. So we've got in our CSS, we've got CSS theme files. We've got the relevant map files so that when you're debugging in your browser, it knows how to map the minified version to a normal version so you can debug it properly. Bootstrap has its own bunch of fonts. Got its own JavaScript, and then all the other libraries have their own JavaScript stuff as well. And sometimes they come with minified versions, sometimes they don't. So that's the way it is. And then of course we've got this ugly build.gradle here as well, but we'll get around to fixing that a bit later. So yeah, as I said before, it's a bit old school here. There's no, I didn't find any package manager like npm anyway to basically find a way around npm so everything we just downloaded ourselves. But it wasn't too bad given that there was only 4 in this one. And then the thing that you have to do next is obviously configure your libraries in your HTML. So it's just relative to index HTML. It's pretty straightforward. But we want to also move away from this because that's not really maintainable going forward. Okay, that's what I just showed you. All right. So, just give me one sec. Oops. Sorry, guys. All right, so the first, with CSS, you're just specifying a source set. So that was, let's see if I've got this here. I'll go through, I think I've got a source set later on to show you. But basically every task depends on the task before it. Let me go back here. All right. So, oh, sorry, this is the source set. We've got we're specifying where our dev stuff is. It just lives in this app/styles directory, for argument's sake, what we're saying to include and exclude. And it's just got to grab everything in that directory. Yeah.
How are you controlling the cascading order?
So that's a fantastic question. In this case, we're lucky, but there's another way, and I'll talk about that in the JavaScript files, where you can actually just ignore this or get the files and have different source sets for different orders. But it looks better in code rather than me trying to explain it. Okay, so yeah, combine CSS basically takes all the source sets here, and this .files method will return you. Can't remember if it's a file set, but whatever the Gradle collection of files is, and you can manipulate this as a list in Groovy. And we're just specifying our destination. And this is kind of important because, it's useful because then what you can do is you can you just simply say here, combine CSS over here, and that means I'll refer to this task over here. It's implicitly, there's a .dest on the end of that guy, but it's basically connected this destination here So you can basically build your pipeline of your tasks. And so here then we're basically saying after we do our minification and put this thing over here, we can then go and use that as the input to the next thing. All right. So yeah, this is just running through, combining the CSS, it's fine. So we just get one file which is in our build directory with all our stuff included. Then we are doing minification. So it realizes that the combined CSS has already been run. So it just runs the minify CSS. When we check the build directory now, we've got our min CSS file. And just to prove it, when we cat it all out, that's all one. And then, of course, gzip. And so when we cat out this guy, well, for one, it's smaller. So, and then the next thing is it's smaller, and then it looks like what something gzip you'd expect to look like. All right. So to get to the question earlier, with our JavaScript, there's obviously a lot of ordering. So for example, our core, we made a collection of core, and we had this init.js, which was all our constants that we used throughout our JavaScript web app. And so we just use this as a way of divvying up I'll actually just jump ahead for a sec. Yeah, so divvying up the different libraries, and we could basically build a collection of stuff. So extern libs uses this bootstrap path and Ajax loader path. These are just from the Gradle.properties file, so we can just specify version numbers in there. What else? So core. So yeah, core's all the jQuery that you need. Yeah, config and init stuff. And then through our application, the components of the application are there. Just makes it easier to appreciate what the app's doing and the different components, given we don't have packages or anything as such. Yeah, that hopefully makes sense. So that's the ordering, and then that's our really makeshift ordering of the dependencies, is how that's represented in that order. Does that
Oh, that's fine.
clear? Yeah.
The
Yeah. So if in that same way, that's how I'd tackle that guy. The other cool thing I should show is I don't know if you already know this already, but in the source set you can iterate over each one, and then using Gradle's logger property, you can just use it to debug stuff. So it just helped when you don't know the ordering of things, and then you can get it all together. All right. Minification. So the cool thing about this, minification sounds really boring, but it's actually doing a lot of stuff behind the scenes. So you've got like a simple level of minification where you're just taking variables and renaming them to letters, but you can't do that in certain circumstances where there's a bit of a hierarchy going on, or you're referring to an external variable name. So there's a whole different level of minifications that you can do. But the plugin lets you do a few cool things. So you can specify your destination file. You can create a source map file that you can put into Google Chrome. And then one of the cool features here is then you've got some, I guess, more like Java, where you've got things that you can do at runtime. So an assert statement would be a good example of that. So where in Java you've got assert, and you can just do -ea, and that doesn't happen. You can that doesn't happen when you leave off the -a flag. You don't get your asserts happening. You can sort of simulate some stuff using some flags within the closure compiler. So let me see if I've got this here. So what we do, you can basically look up, this is linked to in the documentation, but the compiler options that the closure compiler gives you. And you're basically, what you're doing is you're defining some stuff. So it uses this JS stock mechanism to look at how to optimize your JavaScript code. And what we're doing here is, we're basically telling it that it's a Boolean. We're telling it it's a constant and type. And then when we run the closure compiler, it'll either give us warnings, or if we're doing something really bad, it will probably fail. But it's what we're doing here is basically defining this debug flag as a constant, and we can swap this in at build time. So within our JavaScript in our app, we've just got some stuff here to happen in debug mode. It looks a little bit hacky, and that's probably because it is, but it does the job for us. And then if you basically if you switch it to false, then you don't have to worry about that code actually making it into production at all. So yeah, as I said before, the plugins were already there in Maven and other projects. So another project that's really useful is Row4j, but it's works with Maven only, but it does basically the same thing by wrapping up the same tools. Though it does have a few extra things like SAS support and I think CoffeeScript as well. So let's just go. This is just chaining everything together. So what's going on here is that for some reason you'd think that it would make sense that by default your minify should depend on this happening first, but it doesn't. So if you run minify, it'll basically say, oh, I was expecting some file located in compine.js's dest location, and if it's not there, it'll still try and run minify anyway. So we put this depends on just so that Gradle will actually follow onto that chain, so that you can just run minify.js and it will run combine first, and the same thing here, combine gzip will run the minify.js. I don't know why that's not included by default with the plugins, but probably a future bug request or patch, I suppose, would fix that up. So I will show you some code. Let me jump out of this. Okay. So, you guys see that okay? All right. So what we've done here is we're including the Tomcat plugin, and we're just requesting, this just comes in the documentation as to what you need to include, what dependencies you need to include for Tomcat. So it's just a copy and paste job there. There is some issues with the logging, which aren't quite resolved. So because Gradle's got its own, I believe it's its own SLF4j, when you go to run Tomcat locally, you'll get this thing saying, oh, I've got too many SLF4j bridging jars. And I haven't quite worked out how to best resolve that. There's an open bug which is basically saying we'll fix this in Gradle 2 or later when we get around to sorting out the class paths of stuff when we run. So when you're running the embedded Tomcat, it's using the same, all the same class path of what you've got before. So, configuration, we obviously started with Jetty with this app. But basically we're just referring to some properties for the stop port, and a stop key is just a arbitrary string that you can put in to say this is what I'm trying to stop. You can configure your context paths. You can set SSL to be true or false. We just added some logging in for each of the tasks. So this is quite useful. We're doing the same thing for each. For both of these tasks, we want to just have a do first going on both of them, just to have some notification that the task is, we're just about to start it, because normally the task will simply go, doing all these things, and then you won't see any console output until Tomcat's actually started and taking requests. And the other thing was that when we enabled SSL to be true, normally by default it will only tell you the HTTP URL, not the HTTPS URL. And if you set up your container so that it's SSL only, then a lot of devs will just go to the normal 8080 URL and go, oh, this isn't working, because they won't get redirected or anything like that either. So it's just something to keep in mind. Yeah, and so you've got just run and run var. I think that's pretty straightforward as well, the difference between the two. And what we did, I'll go into that a little bit later. Just go back into this. The other thing I wanted to show you here was basically, because we're in Java land, we can use a lot of Java stuff. So we can use the Java AWT desktop class, and it's got a static method called browse. So that'll just use the OS's open method basically to open that URL in whatever browser that you've set up by default. So we just have this flag to say, do we want to run this task? We have a task to deploy to Apache locally, but we could easily just say Tomcat run here and say that after Tomcat run happens, do this thing, so that when you do deploy it, you'll get to the right app. So it's just a bit of a convenience, and this is something that Grunt and that do as well. So just the equivalent thing on those platforms. All right. So I mentioned before that we've got, when we edit our HTML file, we've got to put our script tags in directly, and that's probably not the most ideal way, because it means once we create minified versions of our CSS and JS, we have to then go and change our HTML file all the time. So one of my favorite things about Gradle, because we can write Groovy code directly in our tasks, is that we can change the script include as well. So I'll show you what we do there. Script includes. Sorry guys. Okay, here we go. So what we're trying to do here is we've got a few different versions of our development scripts, and basically got a few tasks that want to modify the HTML page. So our default HTML is just DFP PCR. Let me just fix this up. So at the moment, I've got, we're using this thing called head.js. So instead of require, head.js is basically lets you define files as their own modules. So if you use require, you have to structure your JavaScript in a certain way. You've got to have an IIFE and put everything within a certain format. Whereas when you're developing off the cuff, basically head.js lets you define the order that each of the JavaScript files are loaded in. And I'll show you that after. But basically what I'm trying to show you here is that the script tag at the end is what we want to swap out, so that when we've got, if we're deploying, say, to local environment, we don't want to use, we want to use head.js for local dev, but if we're deploying the full thing, we might want to have something different. Sorry, I'm just trying to waste time here. Sorry, I've just forgotten where. I'm having a mental blank here. Okay. So we've got different dev modes. We create our own task. So I'll show you what we're doing here. Our task basically looks for these tags in the HTML file, and it takes in a file, which we specify, and it also takes in the enum up here, the dev mode, just for its configuration, and then an output file to write to. And what we've done is just hard code in here what we want as our replacements for our script tags. So when we're committing into Subversion or CVS or whatever, we just want to have a message to actually remind the developer that they need to run this particular task first, so that it configures the right environment in the HTML file. And then for dev, we wanted to use head.js. For prod, we just wanted to use the minified versions, combined and minified versions of our JS files. And then here this is just the bolt does the work. So here we're checking for the HTML file that we've specified. So within each of these tasks, we're just specifying the input parameters. And then just doing our text replacement, and this is all JDK and GDK stuff, so it's pretty straightforward to do. But it was just kind of nice to have that flexibility to be able to configure stuff, and normally you just wouldn't do this kind of thing otherwise. Don't have any questions about that? Maybe I can show it running. So if can I run that? I don't know if you guys have seen, but since Gradle 2 became RC and switching between Java homes. So if you want to use Java 8, that's fine in Gradle 2, but then you go back to Gradle 1 and then you can't use Java 8 anymore, and you go around in circles, which is what's going on, which I think is what's going on here. So I'll skip on that. But basically, running these two guys will swap out the different parts for you and in your HTML. It's very handy to have. Any questions on that? All right. So you've probably seen this already, but just to make our build script simpler was that we had our standard build.gradle over here, and we're like, yeah, this is getting really, really big. So we started to split out into each concern the different things. So each one of these, well, at the top of the build.gradle, we've got just apply from, which is then calling each of the files. The scope on these guys is just relevant to each. So within each one of these, we apply the plugin and the build script stuff. So what I mean by that is that, say, at the top of the CSS plugin, we do apply plugin CSS. For Groovy, same thing. It's got its own dependencies and its own repositories stuff. Sorry, make that bigger. What else? Yeah, so each one defines their own repositories and dependencies. They don't merge or don't inherit from the root. The only thing that did, generally the build script stuff is supposed to work. So any kind of build script stuff is supposed to follow down the chain. So if I use the CSS plugin here, I don't need to do it in the CSS file here. But I found there was some weird little issues, particularly with the JS plugin, where I had to redefine it for one of the JS hint tasks that it offers. So it just wouldn't work. It would have some class path issues if it didn't redefine it in there. All right. So testing, I'm just going to show you JS test driver with IntelliJ. So have you guys used JS test driver before? A few nods. Basically, what we did is create this configuration file pointing to where to load all the scripts from, and that includes all the supporting JavaScript files. You can use wildcards on there, but then you lose the ordering of stuff, and things don't work. So you get to the issue of what we had before. So we've defined these things here, and then we're defining the test that we want to run there. You can also have an asterisk in here and run your whole entire test suite as well. But I'm just going to show you with this test. So I've just right-clicked and run the test with JS Test Driver. And running. The other thing that you need to do is capture a browser. So JS Test Driver runs in a browser, which I would have started earlier. And yeah, there it is, just so you can see. The weird thing I noticed in Google Chrome is that you have to have the browser tab in focus. But in Firefox and all the other browsers, it's okay. So that was just hanging until I brought that guy into focus, and that was the only reason. It wasn't actually doing any processing of any sort. But now it is hanging. So let me just try stopping that and starting that guy again. Yeah, of course it doesn't want to behave now. I've angered the demo gods. So the cool thing I wanted to show you though was that you've got this auto test mode, and IntelliJ's pretty smart. So it'll watch all the files for changes and basically rerun all your tests when you've got that turned on. There's also a watch plugin for Gradle, which you may have used for Java projects. And you can use that with this thing as well if you wanted to do this from the command line. Okay. Almost done. All right. So the cool thing I think about having this all in the JVM space is that you can use all of the Java stuff. So I showed you the desktop stuff before. The other thing was we need to implement some better security in our app. So when we moved it from just a JS-only app to Tomcat, we basically said, well, we need to redo our security. The neat thing is that in the Java space, we've got Tomcat servlet containers with well-defined servlet spec about how to do security. And so it was really easy to do that. I will show you exactly what I mean over here. So in our standard Java web app project, you've got your webint files, your web XML files, which you can basically start putting, where are we? So you can define resources that are secured. And then because they're running in a Tomcat container or a Jetty container, they'll honor the roles that you've defined. And it's really easy. So from what we do is we just tell the container, hey, when you've got an unauthenticated request, this is where you're redirecting the user to. But you could wrap any kind of security solution in Java that ran on as a filter, so Spring Security or anything else, and get very cheaply some security for your app. So basically, when we go to our single page web app, the user will get redirected to one of these static HTML files. And the old thing, if you remember, was basically you have a form that posts to, where is it? This JSecurity check, your username and password. And as long as you've locked that down with your transport security so that it enforces the HTTPS protocol, you've got something very quick and easy to have. The other thing that we complemented this with was just a Grails app that was basically an admin app for managing users. So I think it was the Spring Security UI plugin with Grails and just a few views on some database tables and hook that all up. So Tomcat and Grails played nicely, but we didn't have to do any extra work, and it was just there for free. And because it's been a problem that been so many times before, it was just a nice win that we didn't have to worry too much about. Okay, this is my last point. So integration with or what we get with Grunt. So we've pretty much got a lot of one-to-one functionality. So Grunt's got a inbuilt server mode. It does all the minification and combining, and it's got a watch mode for tests. But there's some things like Angular directives, which are things that there's no real equivalent for doing in Java. And what most people have done is just use the exec task to call off into the command line and run Grunt directly. So this is just some examples that I've got here. So yeah, here's a Grunt task, and basically you can call, that calls, your Grunt command, and then from there you can have different tasks which are doing calling specific build files, and then yeah, from there we can do anything else that we'd otherwise need. But for that, in our case, we were using npm. We weren't using npm, so it kind of didn't really bother us too much. But we've got a few other projects at Shine where they are actually integrating that stuff in together. So they've got legacy Java apps that they're just basically building new JavaScript UIs for. There's developers there who are traditional Ruby, Sass guys, and they're happy to use Grunt, and just so that they can keep everything under the same umbrella. They'll use Gradle to do their Java side, and then call out to their Grunt tasks, just so it's all in one place, or two places, as such. So. Just some points that I wanted you to get across. Firstly, you can use Gradle to build a web app, and it can be standalone, so go and try it out. Because you've got embedded containers, your developers can get started. They can just check out the project and run it straight from the command line. They don't need to install any other web apps or anything else like that. You've got support for watching over your files and reacting to changes, so it's a better developer workflow. And yeah, you basically, because you've got everything in your Gradle build, you can see end to end what's going on. So you can, it's easier to go through, say, IntelliJ and doing a Control-Shift-Fs and looking through the one project as opposed to going through different projects and trying to piece things together. I think as support gets better later on, people will take better advantage of that stuff, so that your tooling will get smarter to understand different JavaScript and CSS files and the build files behind those to make a better story. But it does help, and you can then have some other smarts around writing your own tasks that perhaps honour some dependencies or do some other magic. So it's worth having. And yeah, because the JVM was more mature, talked to the proxies a lot easier, and yeah, we could see everything in the one build tool. So yeah, these are my details again. I've got a blog which I've covered everything in there, so I'll post these slides up onto the website now, and you can go take a look at those too. But that's it. Thank you very much. Thanks. You got a question?
Yeah, so I just was playing around here, and I see that the JS plugin that Gradle is using, it does like combining minification. In that minification, combining the obfuscation too.
Yeah, so Yeah, so let me go to the Google Closure Compiler docs. Oh yeah, this will work. Yeah, so if you've got the same build stuff, definitely. Okay, so advanced compilation. So you're asking about, the question was obfuscation. So in here, I'm just trying to remember, there's simple optimizations and advanced optimizations. If I remember correctly, then this would let you do a bit more of that, like obfuscate everything. If you use the simple obfuscations, that's where you'll only get the top level. So here, there's replaced the variable parameters. Let me see if I can make that bigger. Yeah, so, but it hasn't replaced some of the, like flower note, it hasn't replaced some of the other things that are referred to from a different scope. I wanted to play with this, but I didn't really have much time, but there's, when you look at the advanced optimizations, you can basically define a file that declares all the variables and all the function names that you want to change, or you want to basically say, hey, I know this variable exists somewhere else, and you can swap these two things around. And there's a whole way of doing this. I'm just trying to find this here. So yeah, you can I think this is it, the declaring externs, and you'll find different externs for different libraries. So someone's already created one for jQuery, for example, and where we were using the Google Charts API, because that was not within our code base, it was an external, that was on the internet. It wasn't something that we had, that we could plug into it. You could define an extern, declare an extern file, which then gave it all the variables that you'd want to swap out in that library. If that makes sense, yeah. And so,
I do a lot of stuff for banks.
mm-hmm.
So we had a tool that was basically reporting some of their services that was called and how many number of instances per, like, let's say a 5-minute interval, and it would chart out with JS.
Mm-hmm.
Give them like a nice graph, and somebody, I guess, in the command center could be looking at that and see, holy crap, we've had 30 errors from this service in the last 5 minutes.
Yep.
Maybe we better check to see if that service is down or what's going on.
Sure.
And stuff. And so we have to, like, one of the things we wanted to use was we wanted to use Angular, but we were worried about, since it's basically replacing your controller, we don't have that control of hiding maybe something that might get away, or business logic that we're doing.
Mm-hmm.
So we just kind of did Spring MVC and then basically pass back generic, this is your object that you're going to deal with.
Sure.
And really try to obfuscate it that way. So that's just why I said obfuscation. Not that somebody could reverse engineer that, but it's if you can get the security department to give you the thumbs up, go ahead and do it. Then that's something that
Sure.
they struggle.
All right. So
if we could figure that out, we could use Angular.
yeah. So there's actually a pattern that we used for splitting out our thing. So just for the recording's sake, the situation was avoiding using Angular JS because you're putting all your business logic in the client, and the client can see that business logic. So one thing with our app was that we were talking to Google BigQuery, and you pay as you go, and so it could be very dangerous for a client to send a big query that's selecting all the columns in your data store and running up really big bills. So what we actually did was, because we had prototyped everything in JavaScript, we had all this code that was formulating our SQL to BigQuery. And it was pretty well unit tested. We didn't really want to rewrite. We knew we had to move it to the server so that the client couldn't see it, but we didn't want to rewrite it. So we kept it in JS land. But what we're doing is that we're defining a servlet that talks to BigQuery directly. And it also, let me see here. All right, so we've got two servlets. We've got a script runner servlet, and the script runner servlet is basically just including a script engine manager, which is Rhino, and Rhino is running the old JS file that we used to run on the JavaScript, sorry, on the client side. Let me see if I can show you that stuff. So here, yeah, basically where this is just in Groovy, but it's a servlet running and it's loading in the JS files that we used to have on the client. We've moved it all in. We're using the script engine manager to load in those report definitions, and we query the old JavaScript code to make that remote call. I think the only thing, what we did here, we ran into a problem where the DOM, basically a lot of JavaScript file libraries expect there's a DOM. And so then when you're running in the script engine manager, it's like, oh, what's this window object? You know, it doesn't exist. So rather than actually trying to fake it out, a better way around it was we could integrate with the Java APIs for BigQuery, and we could inject those into our back into our object. So I'm just trying to remember where the code was here. So here we're injecting the Java BigQuery API and this DAO that we built for that, we're using that to get back some JSON and give that back to the server, back to the servlet. So we're running the query in Java, but then using this toPretty string to get it back as JSON and just give that back to the client. Yeah, exactly. Yeah, so yeah, and so it doesn't know any different, but yeah, it was the same. It was the same code, so we didn't have to touch our SQL building code. We didn't have to touch anything. We just let that run on the server as is, and it was kind of nice. So the only thing we had to swap out was find a better library that didn't use the DOM. And if we did, for other libraries, I don't know what Angular does in terms of, say, if you had like a test framework that you could sort of use that to mock out and satisfy all its DOM dependencies to sort of shut it up, then you could try doing something like that. But yeah, keep it, and that way, yeah, it's in the server, and then you just have to basically make sure that you're maintaining load test it properly, basically, so that it's going to handle the load. Yeah, but it's good. And I mean, this is my favorite part about doing JVM development, because you can mix in languages, and I think it's so yeah, I've got a Groovy class that's reading in some JavaScript and yeah, writing it back out, and it's all just handled in the same spot. And it really entertains me anyway. I think the more languages I can bring in, just for the sake of it, it makes me happy anyway. When I can prove that I can do it. So yeah. Any other questions? All right. Well, thank you very much. You've been a very good audience, very patient, and hope to see you around next time. Yeah. Cheers.